question 9 from Year 11 methods, Year 10 methods pathways, and it's to do with exercise 10.4 on tree diagrams. So we've got a scenario where we've got two six-sided dice are rolled, and we're letting T represent the event that a phrase rolled. And this is the event that phrase rolled on one die, okay? So we've got two die that are rolled, and T is the event that a phrase rolled on one die. So what does not T represent? So not T represents, we'll call not T T apostrophe, meaning not T, okay? Or the complement of T. Not T is not rolling a free. So not rolling a free. Not rolling a free. So it's a chance, it's saying the event of rolling a 1, 2, 4, 5, 6. So it says draw a tree diagram is illustrate the situation. Now you might be tempted to draw a really big tree diagram and go 1, 2, 3, 4, 5, 6 for the first roll, and then 1, 2, 3, 4, 5, 6 on each of the branches there. That's not the way to draw a tree diagram here, because it's defined an event for us. It's defined an event for us that T is representing a free is rolled. So we can have two branches. We can either have a first branch being, or the first possibility being T is rolled. The other one is free is not rolled. So a free is rolled or not, free is not rolled. The second round, I can have either a free is rolled or a free is not rolled. A free is rolled and a free is not rolled. And I can write the probabilities on my diagram, because I know the probability of rolling a free on a die, on a single die, is 1 over 6. Remember, however, we have a split on a branch, they add up together. They add to 1. I know the probability of rolling a free is 1 over 6. That's 5 over 6. 1 over 6. 5 over 6. 5 over 6. Now, I need to write my sample space, because it will help us a lot in the question, because we know that the probability of rolling T and a T, or a free and a free, is TT, T not T, not TT, and not T not T. And it actually pays to work out the probabilities before we even do the question, because it saves us a lot of time. So this one, we want the probability for this particular branch or path. We want not T, not T and T, which is a 6 times a 6. Because remember, we look at the probabilities that are on the branches for the path we're interested in, and we times together. So it's 1 over 36. Probability of T dash is 1 out of 6 times 1 on 5 over 6, which equals 5 over 36. Probability of not T is 5 out of 6 times 1 over 6, which is 5 over 36. And the probability of not T is 5 over 6 times 5 over 6, which equals 25 on 36. Now, let's do part C, because we've done all the hard work. We've put our sample space here. Let's interpret the questions that are being asked. So C part 1, possibility of rolling 2 frees. 2 frees is, there's only one possibility, it's TT. And the probability of getting a TT is 1 in 36, or rolling 2 frees. The probability part 2 asks us the probability of not rolling any frees, means there's only one possibility out of a sample space. It's the last one, because it's not T, not T. We don't get any frees in that case. So, which is 25 out of 36. Part 3 asks us rolling only one free only. As you can see, the sample space, TT means rolling 2 frees, T-T means rolling 1 free, T-T means rolling 1 free, and the last one means rolling no free. So the possibilities we want are the two middle ones. So the probability of so equals the probability of rolling one free only would be t, the two middle possibilities. So the probability of t not t and the probability of not t t. So we're going to add them together. I've already done my probabilities, so this makes it really easy for me. 5 out of 36 plus 5 out of 36, which equals 10 out of 36, which equals 5 over 18. Part 4 asks me least rolling one free, okay? At least rolling one free, which means we can have two frees or we can have one free. So looking at our sample space, I know that if I add the total here of all the possibilities, adds up to 1. So this adds up to 1. Because that's our total. Okay. Since I want everything except t dash t dash, because that's the only case where we don't have any frees. Okay. I can use the complement of that scenario to work out the probability of rolling at least one free. Okay, I can use that to so I can go 1 minus t dash, which we worked out in part 2, 25 out of 36, which equals, in case you're wondering how I worked this out, I know 1 is the same as 36 over 36 minus 25 over 36, which equals 11 out of 36. Or, if you're confused about what I did, you can add these three probabilities together, because these three branches all have at least one free in it. This has one free, this has one free, and this has two frees. So you can do it that way as well if you don't get how I did the complement idea. Use the complement idea to work this out. For part 5, rolling no more than no more than one free. No more than one free means that I can have no frees, or I can have one free, but I cannot have two frees. So again, you can use the complement idea, because we're only interested in no more than one free, because we have no frees, one free, but we cannot have two frees because it's no more than one free. So I can use the complement idea again, because I know the whole thing adds up to 1. I can go 1 minus the probability of two frees, and that'll give me the probability of rolling no more than one free. No more than one free, which equals 1 minus, we've already worked out what the probability of rolling two frees are. It's 1 over 36. So answers 35 over 36. 36. Okay, and that's how you do question 9.